Alrighty, let's look at section 3.5. It just happens to be an application, but one of the main reasons I want to look at it is it adds some nice things in the print that would be good to know. And so let me highlight it and go back over here. I opened up a cell, and there we have the definition, and I can call it then with SEQ3NP1, and of, maybe 12. And if I run that, it's an interesting sequence that you get here. 12, 6, 3, but then it goes up to 10, then 5, then 16, then 8, 2, 4. So what's interesting about this sequence is, and I don't really know much about it, but it appears, just from looking at this, the way it works, is that if you perform these sequences where if it's an even number you divide by 2, then here's the odd number. If it's an odd number, you multiply by 3 and add 1. That eventually it hits on a number that is 2 to the n. And then once you're at 2 to the n, it will head back to 1 because you just keep dividing by 2. Okay, so that's one thing, and let's look at how they did that. They said, and this is a good application of the while loop, because they want to run this until n is 1. So while n is not 1, they will print n, okay, and a comma after it. Now, and this is the interesting part here too, about how they made the numbers go sideways. So by using this end equals in a comma, what it did was it didn't put a carriage return on it. And a carriage return is just that, from the old typewriter days. You don't know what typewriters are, but it went, a carriage moved across, and when you got to the end of your line, you would do a carriage return, which was that it went back to the left-hand side of the page, and it went down a line. So what we would call a line feed, and then a return to the first spot on the left. Okay, so it's this end command, and here they just put a comma with a space, and so that's what it's doing. Then they check, so if it's if n is divisible by 2, in other words, if n mod 2 here is 0, there's no remainder, then divide n by 2. And they're making sure that it's integer division. And then else, well, then n is n times 3 plus 1. And so here we're doing that redefining of n again, and here redefining of n. So we don't put a new variable, we just do this calculation and then put it back into the drawer that happens to be called n. So we take it out of the drawer, divide it by 2, and then put that result back in the drawer. Same thing here. And then here they finished up the thing, and they put a period. I don't know that you really need a period, but they put a period, and then the backslash n is just that. It's a carriage return line feed. So it got to the end of the line, and the next time you print, you'd be back over here. And so, let's look at, right, before we saw these print statements, we would have just done something like this: print n, and then down here the same thing. So I'll copy that and paste it and comment it out here. and just put the n here without that. And so if we do that and run that cell, you know, we get that same sequence, but boy, that's a lot less satisfying. So this is just, you know, ways to make your output prettier, and they just sort of sprinkle in some of these ideas as they move along. But this is a nice one, definitely. And so we'll put that back the way it was. We'll get rid of those. And so if we run it again, we'll get all that in one level. But you know, this is again a very nice use of a while loop, because when I give you the number 12, I have no idea how many of these iterations it's going to take, and that's where the while loop is nice. I can just have it stop once we get to 1. And it turns out this is never an infinite loop. It will always end up back at 1. And like I say, I don't know much about the sequence at all, but it does terminate. But I don't think anybody has any real idea, like, about how many steps it will take given any number. You know, so 12 is smaller than 13. This took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So does 13 automatically take more? It looks like it took the same. You know, but if I give it 16, it's kind of obvious from here that it's only going to take that many. And so, you know, it's just an interesting sequence. And I think for 7.5, let's see, let's look back here. You know, so they mentioned this application, and again, it's very nice because I don't know how many times, but I do know when I want to quit. So that's a nice place for a while loop. And here they give a bunch of the numbers, and here they just talk more about that, the problem itself. And what they here, so they are, you know, so choosing between for and while, and they finally talk about it here, is a for loop. Usually you know exactly how many times you need to do something, and that's definite iteration. But then for something like this sequence, since we really don't know when it's going to end, that's an indefinite iteration. You know, we're just not sure how many times it's going to take. And so that's you know, that's our technical terms for these two cases, the for case and the while case. Alrighty, and I think that does 7.5 just fine.